Welcome. This is part 2 of my introduction to TensorFlow. My name is Jack Brzezinski, and this time I will be talking a little bit about the installation process, the libraries that are not necessarily part of TensorFlow, but would be essential to manage projects the way I guess TensorFlow is intended to. And a little bit of kind of basic execution related stuff. My background is in artificial intelligence, mostly natural language processing, high dimensional data sets, and so on. I'm also very interested in robotics. And this tutorial or introductory material is really meant to kind of go over the installation process and creating a useful environment. The next material that I'm thinking about will be really about machine learning. Because I have a feeling that once you start actually discussing a problem, Tensor tool it's just a TensorFlow is just a tool, and really it's the machine learning aspects and the AI stuff that is of primary importance. And TensorFlow is really very convenient in a lot of aspects, or the Python environment and the libraries that I will be suggesting in this material is really creating a very interesting and very convenient workflow. But the foundation is really what do you want to accomplish, how you want to build the model, and what do you want to do with the outcome. Right, so the platforms that I prefer are really based on Linux. For this material, I went through the process one more time on my Linux Mint, and the installation process was really easy and really seamless. It really takes, only minutes to get TensorFlow up and running on Linux environments. Right, so what you are looking at is just a installation process, and once you install your environment using the commands that are displayed here, and also, if you want to see more extensive material, go to tensorflow.org. They have excellent step-by-step tutorials, and really this is a really quick process. One note is that the way I installed TensorFlow was for CPU installation only. One of the tremendous advantages for TensorFlow is that if you have strong video card installed, some people really have very powerful computer graphics, gaming systems. Then you can take advantage of the tremendous horsepower that those video cards possess and install TensorFlow as a GPU-centric environment. So here I just installed TensorFlow on my simple computer with basically a strong CPU, but no GPU to talk about. Right. So once you are done, basically you can execute TensorFlow and basically type from the command line, the commands, import TensorFlow and then presenter, and then just go through the process. And once you execute the print command and execute the let's say the addition command, you will be able to see that the environment that you installed is really able to access the resources and produce some results. So if this demo works, then you are basically done with the baseline TensorFlow environment. Obviously, once you are once you are finished installing TensorFlow, you can simply start writing code. Here is my little program in Python, test1.py. And this is the same program that I installed, that I execute from command line a moment ago. So that command line worked, so chances are that this thing is gonna work as well. So just type python test1.py, and you will see the same output generated in your terminal environment. One of the most attractive tools that will be available to you is the TensorBoard library. So what TensorBoard does is basically starting a web server. So once you execute TensorBoard and provide some sort of allocation information, just make sure that you have proper access to that location, read and write privileges. Then you can see that there is going to be a port generated, 000:6006. So once you navigate your web browser to that URL, you will be able to see that your code that you are running can be visualized, and you will, and here, there is not much to see because I basically have two simple variables to talk about, but you will see a graph that will be showing you the structure of the code that you wrote, right? And this is all done by the writer command that is going to output to the directory that you specify. So TensorBoard would be a tool that is going to be helpful for bigger projects because it will give you some sort of a code structure visualization capability. Now, once we have the examples up and running, and basically we verified that that the libraries work properly, then it's time to start looking at resources. What can I do to kind of get going with the code? And there is tremendous amount of resources online. Probably the first one would be the API, the TensorFlow API, which will be quite informative and probably will be something that you will keep open on your computer all the time. Right, so the bottom line here is that you have a certain way to represent variables, and they are basically matrix representations, and that you have a lot of libraries that will create machine learning models for you from the data that you supply. So in itself, this is nothing unusual. There are many other machine learning packages that will do exactly the same. One characteristic that probably is going to be a big advantage for TensorFlow is that capability to run your code on your graphics, on your GPU, on your graphics hardware, which will be a tremendous advantage in terms of computational efficiency. But the bottom line is that obviously, if you are familiar with AI and machine learning or statistics, then really TensorFlow is one of the more convenient tools to build quick, relatively quick code that generates machine learning based outcome. and really because you are in a because you are most likely in the Python environment, then your machine learning solution is really not just an atomic process that can do X, for example, train a neural network. What you can do is you can build a solution that involves many steps. Some of them might be machine learning aspects, more than one. Some of it might be data processing aspects, many steps. So taken together, the community is calling that kind of environment a deep learning environment where it's really nothing new. It's just that you can conveniently package multiple solutions in one Python script. So if we are talking about deep learning now, and the concept that really it's not just going to be this one application that is your neural network that is going to do the job. If you have the capability to implement multiple rather complex steps in your data analysis or whatever you need to do into one, let's say, Python program, then really we need to look at, okay, so what else? What is going to be the deep learning paradigm that you will be applying? Is it just going to be TensorFlow by itself? Or the deep learning is really taking advantage of the other libraries that you might be needing for your, for example, data pre-processing. So, for example, you are working with huge amount of tabular data, and let's say you would like to do some sort of dimensionality reduction pre-processing step in your program. So is this program going to be like a separate application, or do you want to put it into a single deep learning chain? So if that's the case, then it really makes a lot of sense to build your deep learning environment with additional libraries that are not TensorFlow, not part of the TensorFlow package. So, so my suggestion would be to look at scientific Python, Scipy, which gives you a bunch of libraries that are really extremely convenient, extremely useful for a lot of applications. So Scipy. Now, the next thing to look at would be the so-called scientific kit, which is basically a wrapper that puts together multiple libraries that otherwise would be a little bit less convenient to use. So scientific kit is basically putting together another set of tool for the user. Here an example is nice plotting capability. So scientific kit learn is my another recommendation. Right, and some people would say that if you have the scientific kit and TensorFlow installed, then the new the new name or the new label of your environment would be scientific kit flow. Right. So again, that environment gives you a more convenient access to certain modules, like for example classification and clustering and all the machine learning kind of foundation that you really need to run if we are talking about TensorFlow and deep learning. The only note here, when you are installing the libraries, is that you have to kind of watch what are the versions of Python that you are running, what are the versions of the libraries that you installed, so far, especially the NumPy, numerical Python, and Scipy, you might be running something that is older, so you have to verify the versions, as you can see here. So fortunately, the resources about the scientific kit are quite extensive, so it's really easy to figure out what is going to be needed to create that kind of environment. So scientific ScikitFlow is really kind of giving you additional convenience to already conveniently packaged TensorFlow libraries, in my opinion. And so the installation process is relatively simple. However, I have to mention that I had a little problem with installing scientific kit flow on my Linux machine. I'm pretty sure that with a little bit of investigation, I will be able to kind of track down the problem. On my Mac machine, the installation was much easier. So I'm just sure that this is kind of a versioning issue, but from time to time, these kind of installation problems might pop up. Right. So with that kind of environment installed, you should be able to really tackle very complex and ambitious deep learning problems. If machine learning is not your primary area of focus, and you want to do deep learning, then probably it should be a little bit more challenging to build efficient solutions. Therefore, these are the resources that I personally like. From the time I was a graduate student up until today, these are very good books to have. Particularly Tom Mitchell publications are really excellent. His machine learning book is something that I probably learned by heart. Anyway, my next video is about TensorFlow. Is really going to be a video about machine learning, or deep learning, if you will, where the tools that involve TensorFlow will be not the primary concern. The primary concern is going to be looking at the data and then analyzing, building properly the models, verifying and analyzing the outcomes. So this is basically it for today, and thank you very much for watching.